Hello, boys and girls, and welcome to another Mother Manatee math movie where you, yes, you, get to play the therapist and solve all of math's problems. Today, we're going to be talking about some angle measures. It starts on page 36 in your book, so make sure that you're ready. You got your notes out, and let's begin. Alright, so the first thing, we're going to start off with some vocabulary, and our first word is ray. A ray is just a part of a line where it has an endpoint on one side and goes on forever in the other direction. For example, here we have a line MP, or not a line rather, but a ray, and we can name this with the word ray MP. M comes first because this is the side where it ends, and P is the side where it goes on forever, and we know that because of the arrow. We can also name it with just writing letters MP with an arrow over the top. You can notice that on one side it ends, and on the other side we have the arrow which tells it goes on. This means it's a ray. The other way that we can name this is ray MO. Again, M being the first letter because this is the side where it ends, and O because it's going to go on forever on this side. We can name it again simply the letters MO with the arrow over top. The next word is opposite rays. And opposite rays are determined by a point. The opposite rays share a common endpoint, and they are collinear. I didn't take a picture of this one, so I'm going to draw this one, but if you want to look in your book, you can. There is a line with H, J, and K on that line, and you have ray JK, and you have ray JH. Both of those are on the same line, but they go off in opposite directions. I could do a ray like this if I were to extend this line, and I could put point Z, and there's my ray, and then now XY is an opposite ray to ray XZ. They share the common point X, but they go in different directions, but they are collinear because they're on the same line. The third one is an angle, and an angle is formed by two non-collinear rays that have a common endpoint. So this is kind of the opposite of opposite rays, where opposite rays are on the same line. An angle is formed by two rays, here ray XZ and ray XY, that are not on the same line, but they do share a common endpoint. That endpoint, as you can see, is called the vertex. So we're going to call this would be vertex X of this angle, or angle 3. Also the sides, we can name them side XZ, right here, and side XY. Some more vocabulary that we need to know. These aren't too bad. You have the interior and exterior. Like the interior is the inside of your house, it's also going to be the inside of the angle. An exterior, as it is, be like the outside of your house, it's going to be outside the angle. So some points that are on the interior are R and S. Points on the exterior are P and O. We would say that Q and N, and also M, are neither. They're not interior, but they're not exterior either, because they lay on the line. So now we can get into some examples. This is real world example number 1. They want us to use this map shown, and they want us to do different things with this map. Letter A, it says they want us to name all the angles that have B as a vertex. Okay, so angle B right here or not angle B, but point B as a vertex. And remember, the vertex is where two angles meet, or two sides meet. So I have angle 1, which is right here, that has vertex B. So I could label that as angle 1. Or I could also name that angle A, B, D. I could also name that angle D, B, A. Right? So you can name it with the number, or you can name it with this a point and then the vertex, like I did, and then the other side. Or you can go the other way if you want to and name it with this side, then the vertex, then the other side. Either way is acceptable. So that's one angle with the vertex B. Now the other one would be angle 2, or it would be angle DBC, or it could be angle CBD. Right? There's a lot of ways that you could actually name angle 2. You could name it DBC, DBK, DBL. You can label it LBD, KBD, and CBD as well. So any of those would be completely acceptable. Moving on, they want us to name the sides of angle 3. The sides of angle 3, here's angle 3 right here. The sides would be either CE, or you can name it EC, or the sides of 3 could be CB, CA, or it could be AC or BC. Letter C, what is another name for angle GHL? So what's another name for GHL? We could write this a few different ways. We could just call this angle H. And again, if you haven't picked up on it, the sign for angle is like that. We could call it angle H. We could call it angle 7 because there's a 7 there. Or we could call it, we can't use GHL, but we can go the other way and we can call it angle LHG. And point D, name a point in the interior of angle DBK. So we want an interior point of D, B, and K. So something that's on the inside over here really only gives you one option. That's point E. For the OYOs, I'm going to read off a question. You write down your answer. I'll give you a couple seconds to find it. And then I'll just speak you the answer. So 1A says, what is the vertex of angle 5? What is the vertex right here of angle 5? The vertex of angle 5 is point C. Okay? 1B says name the sides of angle 5. Name the sides of angle 5. The sides of angle 5 could be CG, CJ, could be JC or GC for this side right here. And for this side of angle 5, it could be CB, it could be CA, it might be AC, or it could be BC. You could have written down any one of those. 1C wants you to write another name for ECL. Write another name for angle ECL. Another name for this could be angle C. You might have written angle 4. you might have written angle LCK. You might have written, LCE. You might have written KCE. Any of those would have worked. And the last one, name a point in the exterior of CLH. So here's CLH, and we want a point that is on the exterior of of CLH. So something that's on the outside of this angle. You have two options, and your two options are either point D or point E, because it's on the outside of that angle. All right, I know how much you love vocabulary, so we're going to do some more. Next word that we need to know is a degree. And this is the measurement that we're going to be using a lot this year, and it measures angles. A right angle is an angle that measures exactly 90 degrees. Okay, on the money. Here you'll see that we have a sign. This symbol means a 90-degree angle. So when you see this half square in an angle, that is telling you that this angle is 90 degrees. So the measure of angle A is 90 degrees. An acute angle is an angle that measures less than 90 degrees. So acute angle, here we would have that this dotted pink line right here is a 90-degree angle with the bottom ray. And we have angle B, which is less than that. So angle B is less than 90 degrees, so it's an acute angle. It's cute. It's a cute angle because it's little. And then lastly, an obtuse angle is one that is more than 90 degrees. So here again, we have our dotted line with the half square, which signals that this angle is 90 degrees. But angle C is beyond that, and so it's more than it's more than 90 degrees, but it's less than 180. This is called an obtuse angle. All right, so moving on. This is going to be example number 2. The instructions in your book tell us to copy the diagram below and then to extend each ray, means make it bigger. Classify each angle as right, acute, or obtuse. Then we're going to use a protractor to measure the angle to the nearest degree. Now, if you don't know how to use a protractor, I could show you in class. It's going to be difficult to do it right now. So we're going to forego that part right now and just focus on classifying each angle, and we'll tackle using the protractors in person. So let's start with letter A. They want us to classify MJP. So remember, since J is in the middle of MJP, that is our vertex, MJ to P, and classify that. I see the half square right here, and that half square tells me that this is 90 degrees, and 90 degrees are right angles, so MJP is a right angle. Now I'm going to look at LJP. LJP. And I'm going to think, is this acute, is it right, or is it obtuse? Well, I just got done doing MJP, and I knew that MJP was a right angle. LJP is a little bit beyond that. It's a bigger angle, and anything bigger than a 90-degree angle is obtuse. So LJP is an obtuse angle. Part C is NJP. NJP, right here. They want us to figure out if this is obtuse, right, or acute. And again, I could go back. I see that MJP was a right angle, and NJP is clearly a lot smaller than that is. So I'm going to name that this is an acute angle. It's cute. Alright, now this is going to be example number 2. And they're going to want you to do the same thing that we just got done doing. Classify angles as acute, obtuse, or right angles. The first angle is going to be angle AFB. The second one is CFA. Third one is angle AFD. And the fourth angle is going to be CFD. So pause this video, classify these 4 angles right now, and then unpause it when you're ready for the answer. Alright, let's go ahead and tackle this thing. Angle AFB. AFB. This is going to be a right angle, so AFB is acute. Angle CFA. CFA. Maybe you got confused on this one because there is no right angle sign, but you could have figured it out because look, AF and FE are opposite rays. A straight line is 180 degrees. CFE is a right angle. So the other side, AFC, also has to be a right angle. So CFA, AFC, however it's named, is a right angle. AFD, AFD is an obtuse. And CFD, CFD is acute. Now the part of the instructions said to measure these with a protractor to the nearest degree. I'll show you how to do that. I don't have a protractor on my video. I could hold it up to the iPad, but you wouldn't be able to see it very well. So I'll tackle this one in class. Just practice on naming and classifying the angles for right now. And because I know that you love vocabulary, I have more for you. Last one for this video is an angle bisector. And an angle bisector is a ray that's going to cut an angle into 2 congruent angles. So on this picture, you'll see that we have angle X, Y, Z. Okay? And then we also have the ray YW. We know that ray YW is an angle bisector because it cuts XYZ into 2 different angles. Here's one angle, here's the other angle. And because these 2 are congruent, they're both 80 degrees, it's an angle bisector. Here's where we're going to start doing some algebra. Example number 3. What I'm going to do is I'm going to read the question, I'm going to start working it out, and then you'll probably notice some choppiness because I'm probably going to pause the video as I make it, move some things around, make some smaller. I've already done that in this video with the pictures, but I'm just giving you a heads up to expect that a little bit more because I don't have a lot of screen to write on when I'm solving out long equations. Alright, so let's get started. Let's finish up this last example. In the figure, ray KJ and KM are opposite rays. Well, that makes sense. KJ, KM, opposite rays. Good, we got it. And KN, so here's KN, bisects JKL. So, okay, let's think about this. KN bisects JKL. We just got done knowing what bisecting is, right? An angle bisector. So if KN bisects JKL, we know that angle LN or LKN and angle JKN, they have to be congruent because KN is the bisector. So LKN and NKJ are congruent angles because KN is a bisector. Let's read on. If JKN equals 8x minus 13 and NKL equals 6 plus 11, find JKN. Alright, there's a lot of letters, there's a lot of numbers, there's a lot of angles and stuff, so this is how I recommend that you start doing these problems. First, read it once, all the way through, even if you don't understand it. Then the second time, take it piece by piece and start putting them in the place where it goes. This is what I mean. Let's start here. We already know, I've already done a little bit, where KN bisects JKL. So because I know that KN bisects JKL, I put these little marks here to remind myself that these two angles are going to be the same. Now let's read on. Angle JKN is equal to 8x minus 13. So JKN, this angle right here, is the same as 8x minus 13. Let's keep going. And NKL, or NKL, this angle right here, is 6x plus 11. Okay? What they want us to find is they want us to find the measure of JKN. Okay? So what JKN is going to be, JKN is going to be these two added together. But if you just add these two together, it's not going to do you very good because you can't, you don't know what X is. So you have to find out what X is first. That's your first step. Alright, so there was our first dramatic shifting here. So what I'm going to do is I am going to set those two equal to each other. So now I'm going to work way over here. Remember when these two angles were equal to each other, JKN and NKL were equal angles? And NKL is 6x plus 11 and JKN was 8x minus 13? Well, I know that they have to equal one another because KN is the bisector and these two angles are congruent. So I'm going to set these equal to each other, and I'm going to do 6x plus 11 is equal to 8x minus 13. Now I can solve for x, and we're going to solve for x by doing algebra. We're going to add 13 to each side. What I get is 6x plus 24 equals 8x. Then I'm going to subtract 6x. And I'm going to get 2x over here and get 24 there. Now to solve for x, my last step would be to divide by 2. And divide by 2, and I get x is equal to 12. Now I know what x equals. If you thought you were getting away from algebra, think again. You're going to be doing algebra a lot this year. You're just going to be doing it with geometry too. Lucky you. Now the problem is not what x is. You have to read what they're asking for very carefully. They're not asking what is x. They're asking what is JKN. So you need to be mindful and read the problem and find out what they want. They want JKN. So let's go back up here to what JKN is. JKN was 8x minus 13. Now I know what x is. So instead of x, I can write what I found x to be, which would be 8, and then x is 12 minus 13. This is angle JKN. 8 times 12 gives me 96. And then you're going to minus 13. 96 minus 13 is 83. So angle JKN is equal to 83 degrees. Now, since you found JKN, if the book asked you to, you could also find NKL pretty easy without having to do any math. Because they're both congruent, NKL also has to be 83 degrees. So be careful. Sometimes you might have to find X. You will have to find X in order to find what the problem is asking you for. Some of these aren't going to be fast. They're not going to be quick. But take your time, get it right, because that's why you're here. That's why you're in school. Alright, this is the last example for you to do, an OYO. This one is tricky. Here, you have JKL is 9y plus 15. So JKL is 9y plus 15. It's the whole angle. Then you have JKN is 5y plus 2. They want you to find the measure of JKL. Alright? So you're given this angle right here, JKN. You're given JKL, and they want you to find in degrees the measure of JKL. This is tricky. Think about it. Think of it like a puzzle where you got to figure it out. Take some time, pause this video, please. Try it out, and then unpause it, and we'll work it through. Okay, let's see how you did and what you did. Follow along with me. First thing, remember, reread it if you need to. It's in your book. It's a guided to practice number 3. First thing is we know that we have the big angle JKL. And we know that JKL, well, that's not 9. We know that JKL is 9y plus 15. Okay? We also know that JKN is 5y plus 2. Now that's not going to work. Here's why. 5y plus 2 is just this side of the angle. It's just this half. JKL is the whole thing. What we don't know is this half right here. And maybe you got to that point and you didn't know what to do. Well, think back to the problem. Do you remember when it said that KN bisects JKL? And if it bisects, what that means for these two angles? That means that they have to be the same, right? So what you should have done, is you could add another 5y plus 2. And you're asking me, hey, where'd you get that from, Buster? Here's where I got it from. JKN is 5y plus 2. KN is an angle bisector. By definition, since it's a bisector, the other side has to be equal. Well, if it has to be equal, if this side is 5y plus 2, then this side has to be 5y plus 2. And when you add them both together, you get the whole big angle, or 9y plus 15. So when you add those two together, you'll get 9y plus 15. So let's work this out, and let's see what we come up with. Let's combine this stuff on the right side first. 5y plus 5y is 10y. And 2 plus 2 gives me 4. On the other side, I still have 9y plus 15. Let's subtract 10y from each side. Oops. Subtract 10y. And I'm going to get negative y plus 15 equals 4. Let's minus 15. Minus 15. And we're going to get negative 11 equals a negative y. And then we are going to divide by negative 1 or move the negative and get y equals 11. Awesome. We're done. No, we're not. If you stop there, you're not done. The question didn't say find y. It said find JKL. So to find JKL, you need to plug it in to JKL, which is 9y plus 15. So angle JKL is going to be equal to 9. Now that we know what y is, it's 11. Plug that in. And then we're going to put 15. So we put 15 in there. Now let's just solve. 9 times 11 is 99. You're going to add 15 to that. 99 plus 15. JKL equals 114 degrees. Don't you feel so accomplished? If you got that right, kudos to you. If you didn't, keep trying. They're kind of like little puzzles. They're kind of fun. Just sit down, take your time. You guys can get it. I know you can. I am tired of this video. I'm sure you are tired of this video. So we're going to be done. Let's wrap it up. Make sure you've taken some notes. I'll leave you with your your joke, because I know you look forward to those. That's the only reason why you tune in. I know that, and because you have to. Here's the joke. What does a nosy pepper do? The answer is that it gets jalapeno business. Alright guys, thank you for tuning in. Hope this made sense to you. Remember to write down any questions that you have. I'll be glad to answer them as soon as we can. Have a good one, guys. Talk to you later.